We're going to continue looking at what the domain, range, and if we have a function based on graphs and or sets or intervals, however it is presented to us. As a recap, the domain and range, they are the input and the output. So the input usually is our x values. And on a graph, we read them from left to right. The range is the output, so whenever I plug in the x value into my equation, I get a y value. And they are read bottom to top on a graph. A function is a graph or a set of points where no x values repeat. A one-to-one function is when there are no x or y values repeating. So a function, we can tell a function is on a graph if it passes the vertical line test. A one-to-one function has to pass both the vertical line test and the horizontal line test. So as long as it passes the vertical line test, we have a function. If it passes vertical and horizontal, we have a one-to-one function. It is possible to have a function, but not a one-to-one function. And we can see some examples of that later on, possibly. So all these problems, we are tasked with finding the domain, the range, if we have a function, and is it one-to-one. So again, domain is x values left to right. So in this graph, I want to start at my left. I see I hit right here on the left-hand side, and starting from the origin, I see I go left 3 spots. So I'm starting at -3. And it's a solid line all around, so everything is included in here. And I look to see where I stop, which is over here on the right-hand side, which has an x value of 1, 2, 3, +3. So because it includes everything between -3 and +3, I'm going to be using brackets. The range is being read bottom to top, so I start at the bottom. I see that I hit the bottom of my graph here, right here at the origin. So the y value is 0. And I go to the top, and I go up 1, 2, 3 spots. So I go all the way to 3. Again, solid line all the way throughout. So we are including everything between 0 and 3. So brackets. Do we have a function? So again, all I have to do is draw a vertical line through this graph. So I draw a vertical line. I say I hit 2 different spots here, which means it is not a function. And because it's not a function, it is not one-to-one. Number 2, we got to be careful because we have aligned arrows. Yes, arrows are physically right here on the graph, but arrows also mean they go forever and ever and ever in that particular direction. So off to the left, it's going down and left forever, and it's going up and to the right forever. So the domain being read left to right, the arrow indicates going left forever. So left means eventually we're going to go to -infinity. To the right, I follow my line. I see I'm going up and right forever and ever. So eventually I'm going to hit +infinity. Now, because technically infinity is a made-up number, we can't possibly hit it, so we're going to use parentheses. So this notation means everything between -infinity and infinity. And the range, we're going to follow the same logic. We have arrows at the end, so this means we are going down forever and ever. So -infinity. And then we are going up forever. So +infinity. And again, close parentheses because we don't technically hit infinity. Do we have a function? All I have to do is draw a vertical line. It could be anywhere. So anywhere I draw a vertical line here, I'm only going to hit 1 spot. So yes, we have a function. Is it one-to-one? So I drew my vertical line. Now I have to draw my horizontal line. So here I only hit one spot, and I could draw a horizontal line anywhere on here. I'm only going to hit one spot. So yes, it is 1 to 1. Number 3 is a little tricky, the domain and range. So here we have a nice solid line over here. Left to right, I see my line is going vertically at this point right here, which is 2. And I'm not going right at all, but I am solidly hitting 2, so I am going to enclose it in brackets. The range being bottom to top, going down means we are going down forever and ever, so negative infinity. And then the range, I'm going up forever, so that means we have a positive infinity, closing with parentheses. Is this a function? If I draw a vertical line on top of my vertical line, I'm hitting everything, so it is not a function. And because it's not a function, it is not 1 to 1. So vertical lines are a little tricky. The domain is the only number that it passes through, in this case x, the range, bottom to top, negative infinity to infinity. 4, I give you the domain of this, and the range, is it a function 1 to 1? So here we see we have 1, 2, 3, and again, solid dots. So I'm just going to put the x values of our dots. So I go left 3, so negative 3, negative 2, negative 1, 0, and then I got a dot down here, so 1, 2, and then 1, 2, 3, 4. So this is my domain. And then my range is going to be bottom to top. So 1, 2, 3, 4. I'm then going down 5, so negative 5, negative 1. At that dot, I have a dot over here right on the x line. That's a y value of 0. Then I go up one spot to get that point right here at negative 1, 1. I go up 2 spots. And then I see I have 2 points up here at 4. Is this a function? So in order to tell if it's a function, do my x values repeat? I see 1, 2, 3, 4, 5, 6, 7 different dots. I got 1, 2, 3, 4, 5, 6, 7 different x values. So yes, we have a function. Is it 1 to 1? And again, the other way, we have 7 dots, and I have 1, 2, 3, 4, 5, 6 numbers in my range. Up here at y equals 4, I have 2 dots, so it is not 1 to 1. Number 5, this one tends to throw people for a loop because it's a fancy S. It's not quite what they're used to seeing. Again, we just look at the fact that we have a solid line, so everything between my endpoint here and the endpoint over here will be included. So this is going to be using interval notation. I need to start off on the left-hand side here. So at this solid dot, I see I have to go back 3 spots. So it's going to be negative 3. And then over to the right, 1, 2, 3 spots. So I'm going to be in between negative 3 and 3. I have a closed dot to start with, so that means a bracket, and an open dot to end with. So I'm going to close it with a parenthesis. That one's pretty straightforward. I can see a starting and an ending point. The range, though, remember, is bottom to top. A lot of people will only count from endpoint to endpoint, but we have to look at the fact that when I come up from the bottom, I hit this endpoint here, which is fine and dandy, but I have to go all the way to the top, which is actually up here. So I have to count the values, the y values that go between my purple lines here. So the y value down here, I go down 1, 2, 3 spots. So I'm starting at negative 3, and then going up to the top, 1, 2, 3. I'm also going up to 3. Again, closed dot on our negative 3, so I'll close it with a parenthesis, and I do solidly hit the 3 up top, so I will close it with a bracket as well. Now, is this a function? It's got to pass the vertical line test. So again, anywhere that I can draw a vertical line and I hit more than one spot, it automatically fails. So here I draw a vertical line, I see it 1, 2, 3 different spots. So it is not a function. Because it's not a function, it's not one-to-one. Now, numbers 6 and 7 are a little bit different. They give us an equation and ask us about the domain range. Do we have a function? Is it one-to-one? The easy way to do this would be to use the calculator. And let me get mine out real quickly. I have a emulator that I use quite a bit. Give me 1 second to get it in. So we're going to use our calculator for this one. This one's going to be pretty easy to use. So on our calculator, notice our equation begins with y equals, up here on the top left, the TI-83 plus the TI-84, all very similar. Up top, any graphing calculator really, you're going to have a y equals button. So in this case, we're going to hit y equals, and we're going to put in what y is equal to as we see it. So negative x squared plus 2x minus 3. And when I hit the graph button here on the top right hand side, it's going to show us what the graph looks like. It comes up and then it comes back down. And we can zoom in, zoom out as much as we want to. So we can see if I were to draw a vertical line through this graph here, I'm only going to hit one spot. So we can tell that it is a function just by looking at the graph. And if I look at it for one-to-one, if I draw a horizontal line across, I'm going to hit 2 spots. So it is not one-to-one. Now, how do I determine what the domain and the range is? Well, I can go to the table in my calculator to take a look at it. So table is in yellow above the graph button. So I have to hit the second button here and then table. And it's going to take me to my x and y values. So if I were to look, I can see that x values go forever and ever and ever. So that means I am going into negative x values forever. So I'm starting or left to right. I'm going negative infinity to infinity. Now the range, we got to be careful because if we took a look at our graph, we can see we come up to a certain point and then we go back down. So if I go back to the table, I know I'm going down I'm going to be at negative infinity because I'm going down forever and ever. But how high am I going? I want to look to see where I start repeating. So here I see negative 18, negative 11, negative 6, negative 3, negative 2, negative 3. Negative 6. So I start repeating. Negative 2 is the highest y value that I hit. So this is one where I'm going to have parenthesis on negative infinity. I do hit negative 2, so I will use a bracket. Number 7 is the same thing. I have an equation. Domain range, is it a function? So I'm going to go back into y equals and clear out my equation. Now y is equal to 0.5 times 3, and then x is our exponent, so we'll just use a little caret and x. So I'm going to look at the graph to see what it looks like, does its thinking, and it comes along and then it goes up forever and ever and ever. Okay, so do we have a function? I can draw a vertical line, and the answer is yes. And is this one-to-one? If I were to draw a horizontal line anywhere, the answer is yes. I have a one-to-one function. So the domain, the range, again, domain is the x values. So I look to see just how far for x I go. and I just get smaller and smaller and smaller and smaller numbers. So 6 e to the negative 13, negative 2 e to the negative 13. That means times 10 to the negative 13, scientific notation. And I can just keep doing this forever and ever and ever. So I'm going to be going to negative infinity. And then to the right, again, if I keep going back into the positives, my numbers are going to get bigger and bigger and bigger. But notice I can keep scrolling forever and ever and ever and ever and ever and ever and ever. So I will be going to positive infinity, and because I can't hit it, I am going to use parentheses around it. Now the range is y values bottom to top. So as you can see, my numbers are getting bigger and bigger and bigger. So it's going to be going to positive infinity. But where do I begin on my graph? Well, again, this means times 10 to the negative fifth. So my numbers are getting smaller and smaller and smaller, closer and closer to 0. But I'm not really getting close to 0. I'm not really getting 0 as a solid number. So we can start off with 0 and go to positive infinity. But because I don't hit 0 or infinity, I'm going to use parentheses around it. Now 7 is saying which does not represent a function, so we can go through these and see which one has repeating x values. So 2, 6, 8, and 9, they're all different. 1, 2, 6, and 1. 1 gives me 2, 1 gives me 8. Two different answers for the x value of 1, therefore it is number 2. Number 8 asks which one is a function but not one-to-one. So function means it passes the vertical line test. So if I draw a line here, I see I had 2 spots, so that is not a function. Number 3